This assessment helps us discover something about this interesting molecule that contains two stereocenters but ends up being achiral. It asks us to do two things. First, draw the mirror image, which I've done here. And second, invert the stereochemistry at each of the stereocenters, which I've done using this molecule. It then asks us to consider both of these new molecules we've drawn and consider, are they actually new molecules? Well, it turns out neither of them are. We've simply regenerated what we started with. Let's see how. Starting with the mirror image, if we rotate this 180 degrees in the plane of the board, so like a steering wheel, we'll end up getting a molecule that looks like this. You'll note that what we've essentially done is redrawn the original molecule. So this 180-degree rotation produces the same molecule we started with. So the mirror image and the original molecule are identical. The other thing we did is inverted the stereochemistry so that now the two bromines are down. We can do a pancake flip, a 180-degree rotation, where we take it and flip it in this direction. And I'm not going to draw it except to tell you that we end up with the same molecule here. So if we pick this molecule up and rotate it, the two bromines that are both pointing away from you are now pointing towards you. The alkene that was on the left side of the molecule remains on the left side of the molecule. And so if we can do this 180-degree pancake flip and regenerate the same molecule, that implies that these two molecules are the same. All of this comes back to what makes this molecule special, and that is that it has a symmetry plane cutting down the middle of a molecule. And so this ends up being a special type of molecule, one we call meso, that has stereocenters, but because it has a plane of symmetry, is achiral.